For this video, we are going to start by looking at conic sections in general form, specifically how to identify which conic is which, or which equation represents which conic, and then we will take one of them and convert it into standard form using completing the square. So here I have four equations of conic sections in general form. And the question is, what kind of conic section do I have in each equation? Well, the trick is to look at the quadratic terms. So let's start with the first one. In this first equation, I only see one quadratic term, y squared. There is no x squared. Whenever we see only one quadratic term, we have a parabola. It doesn't matter what the coefficients on y squared or x squared, whichever one happens to be there. Doesn't matter what they are. It doesn't matter about any of the rest of these terms. If there is only one quadratic term visible, we have a parabola. If we have two quadratic terms, we could have any of the other three. So we need to look at the quadratic terms more closely. If the quadratic terms have opposite signs, like here we see the x squared has a positive coefficient, the y squared has a negative coefficient. If the signs are opposite, we have a hyperbola, which we'd sort of expect since the standard form of a hyperbola involves subtraction. So if the signs are the same, we probably have an ellipse. Again, since the standard form of an ellipse has addition. With one exception. If the signs on the quadratic terms are the same and the coefficients are the same, well, you can picture it this way. We have an ellipse who stretches horizontally the same amount it stretches vertically. In other words, we have a circle. The one I want to look at a bit more right now is that ellipse. So let's put the equation 5x squared plus 2y squared minus 40x minus 12y plus 78 equals 0 into standard form. So the first thing we need to do is group our terms. So I want all of the x's together. So I will start with 5x squared minus 40x. I want the y's together. So we have plus 2y squared minus 12y. And I want the constant, well, on the other side by itself. Awesome. Now we have a problem. When we try to complete the square, we need the coefficient of any quadratic term to be 1. But I cannot divide by 5, because if I divide everything by 5, this coefficient is 2/5. If I try to divide by 2, this coefficient is 5/2. I will not get them both to be 1 by doing division. So instead, we're going to factor the coefficient out. So I'm going to factor a 5 out of the x terms. That leaves me with x squared minus 8x, and I'm going to leave some space. I'm going to factor the 2 out of the y terms. So that leaves me with y squared minus 6y. I'm going to leave some space. And I've got negative 78. What goes in this space? Well, now I'm going to complete the square. So remember, to complete the square, we take half of this middle term. So half of negative 8 is negative 4, and we square it and add it in. Positive 16. But we cannot add to one side without adding to the other. However, this is not just 16 over here, because this 16, along with everything else in these parentheses, is happening 5 times. So this is really 16 times 5. We use a similar method here with the y's. Half of -6 is -3, squared is 9. But that's not really 9. This is 9 times 2. And now let's start simplifying everything. The process of completing the square means this is a perfect square trinomial, so it can factor to x minus 4 squared. Same idea here. This can factor to y minus 3 squared. And now we need to be careful. 16 times 5, let's get this written out, -78. 16 times 5 is 80. 9 times 2 is 18. So -78 plus 80 plus 18 is equal to 20. Now finally, we do not want this right-hand side to be 20. We want it to be 1. So we're going to divide everything by 20. 5 divided by 20 is 1 over 4. So we've got x minus 4 squared over 4. Y minus 3 squared over 2 over 20 is 1 over 10. And that is equal to 1. And this is our ellipse in standard form. Let's look at that circle also. So the circle was 2x squared plus 2y squared minus 32x plus 12y plus 90 equals 0. We're going to follow a similar set of steps. We start by grouping our terms. So we have 2x squared minus 32x plus 2y squared plus 12y equals -90. Again, we need to have 1's here, but this time, since 2 and 2 are the same thing, I can go ahead and divide the entire equation by 2. So I can divide that by 2, 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 and I can divide that by 2, which will leave me with x squared minus 16x, leave some space, plus y squared plus 6y, leave some space, is equal to -45. And now completing the square is fairly straightforward. -16 over 2 is -8. Squared is +64. 6 divided by 2 is 3. Squared is 9. So we have -45 plus 64 plus 9. And we start simplifying. We get -45 plus 64 is basically 64 minus 45, 59, 19, plus 9 is 28. And yeah, that's not a perfect square. That's fine. That means we have a circle with center 8, -3, and radius equal to the square root of 28, which simplifies to 28 is 4 times 7, so that's 2 times the square root of 7. Thank you for watching.